All right, so I'm right here. Welcome back to the channel. My name is Satson. In today's video, we're going to look at one of the most fundamental algorithms in computer science. I'm thinking like, what could it be? Well, are you searching for something? Yeah, okay, yeah. If you're searching for something, then you are in the right place. Today we're going to look at this algorithm. It's called the linear search algorithm. It's known for its simplicity and it's handy in our day-to-day lives. Let me give you a scenario. Let's say you have lost your phone in a room. Well, how do you lose your phone in a room? Maybe somebody stole your phone in a room full of people. Maybe there are 20 people in that room or 30 people in that room. And so how are you going to search for your phone? Obviously, you will line up everyone and then you search them one by one. And that's the idea behind the linear search algorithm. You have to search for your elements linearly, one by one. All right, so let's jump into the illustration. So I'm going to use code so that you guys can understand this concept. So let's say you have these 6 elements and you are searching for a number in this container. And let's assume you are searching for 90. This is your target element. The algorithm goes like, start from the first element, which is index 0. Compare that element with the target. And so it's going to compare 90 to the 20. If it does not match, then it moves to the next element, which is 50. And so it moves one index up. And so it moves to index 1, and so it's going to compare 90 and 50. That does not match, and so it moves again one index up. 90 and 90, this matches, return the index at that position, and so it's going to return 2 for this particular element. Let's say you're searching for 100, and so what it does is, again, your target is now 100, and so what you have to do is start from the beginning of this array, compare the first element to your target, and you say 20, 100 is not the same, and so you move one index up. Compare the next element, it's not the same, one index up, until you exhaust the whole array. Once you exhaust the whole array and you do not find a matching element, then you need to return -1. So -1 will mean the element was not found. It works by sequentially searching one element, comparing it to the target, one element at a time. All right, so let's see this implementation in code. And so I'm going to be using C. We have to create a file here, C file. I'm going to insert, actually include standard IO. This allows us to work with input and output. And I'm going to create our main function right here. Then I'm going to return, we usually return 0 for success. And that's what we have to do. And then here, we're going to declare our function that we're going to use. And so we create a function for the linear search. And so we need to declare it above our main function, and then we define it below the main function. This is the standard practice. And so our function that we're going to create is going to return an integer, as we have seen right here. So we need to return some kind of an index, right? That's an integer. So we say int, and then we're going to call this linear underscore search. You can name it whatever you want. And then in this function, what we need to take as arguments is the array itself. So up here we can see we're going to take this array, so it's going to be an array, so I'll call it ARR array. And then we also need to take the target. Is going to be an integer as well. Target, you can name it whatever you want. We're also going to take in the size, so I'm going to call it the size. So now we are defining this thing right here. To define this thing, we have to put curly brackets down here. So inside here, this is where we're going to define our function. We need to compare the target to the first element, which is on index 0, by the way. If the target is similar to the first element, then we return the index on that position. Otherwise, we move to the next index sequentially. Obviously, we repeat 1 and 2. If we hit the end without finding a match, then we return a -1 here. So we're going to use a for loop int I if I is less than the size, and then we increment our I right here so that it moves. If our array, which is this thing right here, square brackets, and then we put or pass in I, because I will start from 0, incrementing, and then we want to compare if it's equal to our target. Our target is up here, which is this thing right here, to return our I, because we would have found our match. So what return does in a function is it stops the function from executing any further, and then it returns whatever value you would have specified. And so it stops execution and returns it. If we exhaust everything, we find none matching our target, then we must return a -1. Okay, let's go use this in our main function. So the way things work in C is you create your functions and then you can go and call them in the main function, because the main is the entry point and exit point of your program. Okay, so you need to have this main function. So what we're going to do here is declare some kind of an array. We can call it array like this. Right, so this is what I want to mention. When it comes to linear search, your elements do not need to be sorted. They can be in any order, whatever order, ascending order, descending order, or mixed, whatever. They don't need to be sorted, because we're going to iterate through each and every element, so no need for sorting here. And then we want to define our target as well. So let's define our target to be, let's say we're looking for 50, the index that we get. So this is the index that we'll get after we do our linear search. So here we need to call linear_search. And then we pass in our array, which is RR, and then we pass in our target as well. By looking here, we're passing the array and the target, and then we can pass in the size. So how do we get the size? Well, we can do it up here. We can also define the size int size. And then we can use the size of operator, size of ARR, which is this array. And then we divide that by the size of any element inside here, or just an int. So we can say array element 0. It doesn't matter which element you choose. You could choose element 1 to whatever element. So what this does is size of array is going to give you the total bytes of this thing. So we know that an integer has 4 bytes, so it's going to be 4, 8, 12, 16, 20, 24. And he's going to divide that by the size of one element, which is 4 bytes. All right, so we pass in size right here, down here. So we're going to pass in size right here. Okay, we're done with that. And so we can print F right here. And then we say %D, which is our target. We say is on index. And then %D again, which is this index here, /n, and put that. And then so we pass the target, comma index right here. All right, so yeah, this is linear search. Let's the moment of truth. Let's test this out. So I'm going to exit from here. So what we have to do is we GCC our linear. We called it linear.c, and then we want to output it as just linear. So if I run this, it looks fine. There are no issues. If I ls now in our directory, we can see now we have this executable right here. This is the one that we want to run. So to run it, we say dot is the current folder /linear. So we are looking for this linear file inside our current directory. So if we enter that, we can see it says 50 is on index 3. So let's go back and see whether this is true. So 10 is on index 0, 21, 2, 3. Indeed, 50 is on index 3. So we can play around and change again to see whether it's working, really working. Let's do 78, which is right at the end. So each time you change or you make changes to your file, you have to recompile and then run your 78 is on index 5. Indeed, it's on index 5 because 0, 1, 2, 3, 4, 5. Let's try something that is not in this array. So I'm going to try 708. So if I do this, clear this thing, recompile, run this thing, you can see it returns -1. So if it's absent in that list, then it returns -1. All right, so this is linear search in code, and this is how you can implement it. All right, a few things to mention right here. Each time we create an algorithm, we are concerned with the time that that algorithm will take. The number of operations, of course, determine the time complexity. And so we always want to minimize the time. So the downside to this algorithm is it cannot handle huge amounts of data. This one is not really efficient when it comes to huge amounts of data. And so it has an omega time complexity of n being the number of elements. So it takes n operations. If you have 3 trillion elements, it takes 3 trillion operations. It's not efficient when it comes to huge or large amounts of data. But we use this in our day-to-day lives. When you search your phone book, for instance, you go through it one by one, you are using linear search. All right, touching on this code, some might ask, I always had this question as well, why did we have to calculate size in here? Why didn't we just calculate size inside here? Let me do away with size right here. Let's say you were calculating size in here, it does not work. So let's say you put your size right here, and so now you might not need this size, because the reason why we need the size is for us to be looping here. So you might not need this size. But there's a problem with this implementation though. That's why I'm showing you, so that you need to pass that size into your function definition. So I'm going to remove the size right here, and same, we don't need the size right here. Would this work? Well, what do you think? We calculated our size right here. We have our array right here. There's a problem with this code, and so I want you to figure it out. Yeah, if you have a better explanation, you can leave that in the comment section. I think I'll talk about it in our next tutorial. If you find these videos helpful, please leave a like, subscribe to the channel. I'll see you next time. Bye-bye.